Okay, evaluate the limit of the difference function if f of x equals x squared minus 1. Okay, so the first thing you've got to do, the hard part, is find f of x plus h. How do you find f of x plus h if this is f of x? Sam?
Plug in x plus h for x.
Plug in the place of x, put x plus h. So that is x plus h squared minus 1. Okay, now that can be simplified. Right? That is x squared, and it's not x squared plus h squared. It is x plus h times x plus h, which is x squared plus 2xh plus h squared minus 1. Right, that's our f of x plus h. Okay, now we need to subtract f of x. That didn't work. Right, well, f of x is x squared minus 1. Right, when you subtract f of x plus h minus f of x, what you're going to find is that every term that does not have an h in it cancels. Right? X squared minus x squared cancels. Negative 1 minus negative 1 cancels. All that's left is 2xh plus h squared. So then when you add the last part of the difference quotient, then divide by h. Right, the denominator cancels. Right, h cancels with that h, and it cancels one of those h's. So this is what we're left with now. Is the limit as h approaches 0 of 2x plus h. Okay, now try direct substitution. If you say h equals 0, does it lead to anything undefined? No. So this is 2x plus 0, 2x, as Sam said. Right? So with that function, you can find the slope of the graph. I mean, this is a parabola, has a y-intercept of negative 1, opens up. So if I wanted to know the slope for any value of x, then I just plug into this formula. Like if x equals 0, then the slope is 0, meaning that right here, if I drew a line, that the slope is it's a horizontal line. See it? Right? If x equals 1, the slope is 2. Right? If x equals negative 1, the slope is negative 2. So we can use this to find the slope for any point on that graph.